Good afternoon, everybody. I am Shamima Khatun, again presenting you a lecture on microwave and radar engineering. This is my lecture number 2. And in the previous PPT, we have already discussed more about the microwave engineering part. And this PPT will be the introduction to radar engineering. Now let's move forward. First of all, in radar, I have to first tell you what is the full form of radar. So radar stands for radio detection and ranging, where RA is for radio, D is for detection, A is for N, and R is for ranging. So this is all the means basic of what radar actually means. So radar means radio detection and ranging, where radio stands for the radio frequency it's used. Detection means it will detect the target or any kind of object you want, and ranging means it also provides certain information about its nature, shape, its distance from you, and it will also gives your the means idea of, about that target. Okay. So here I had given you that basically all the radars works in X band, but sometimes they also use S band frequencies and Ku band frequencies also. And here the X band frequency you already know is from 8 to 12 gigahertz. I had already told you in the last lecture. Okay, so these frequencies are in the microwave region. X band comes in the microwave region of electromagnetic spectrum. Okay, that is basically used for radar application. And here I have given you a short example with a picturized example of how the radar works. Basically, there is some radar antenna which continuously transmits certain electromagnetic waves towards the target, and basically if the target is not there, you will not get anything in return. But if there is something in the target area, so you will definitely give return echo pulses from the target, and definitely these echo pulses is again been identified by your antenna, that antenna is a radar antenna. Okay, so basically this is a basic example, and it doesn't mean that actually the all the equipments of the radar are made like this. The advanced equipments, the equipments that are used for defense are somewhat having the advanced functionalities. We will discuss them in short in later on. First of all, before going into the detail of what the radar technology actually is and what are all the types of radars and how they work, um, these all will be coming in the next lecture. But in this lecture, also we will discuss further on the types of radars which are being used and what are other applications. But before going into that, I am much more interested to make you understand how the radar technology come into existence. So whenever you are having the idea of evolution of any kind of technology, you will be related to the technology in a much better way. Okay, so starting with the first point, you already know that radar was first used in the World War II around 1939. Okay, around 1940 to 1945. This is the period of World War II, and these are being used very much in this period because this technology is able to detect the bombing aircraft which are coming from the enemy group towards you, so that you can be safe by the time you can detect this aircraft. And this technology, this radar technology, that's why it gained so much of importance at that time to save the lives of many people. But first of all, actually, radar technology is basically the brainchild of the magnetron technology, which is also included in microwave technology itself. So, magnetron is a device which is used to amplify the microwave signals. So, this is an amplifier for the microwaves. And this magnetron concept was first developed by British around 1914s, and it is being shared by British to United States. Okay, and then United States is able to develop radar technology with this magnetron. Okay, so this is being developed by MIT Radiation Laboratory at Cambridge. So the basic work was undertaken over there around 1940s, and after that, more than 100 different kinds of radars were developed by those laboratories in the period of 1940 to 1945. Since you already know that in India was under the means slavery of the British company. So um, in India there is no such development was going on during that period. So you can see that the evolution of the radar technology, the credit goes to, first of all, the credit goes to the Britishers, but actually it is the United States who has taken out the technology into much more specific applications which has been utilized worldwide after that. So first of all, the microwave radar that were developed by MIT Radiation Laboratory were SCR 584. It is a gunfire control system. This is operated in the frequency of 2.7 to 2.9 gigahertz, and this is the S-band frequency. This device is equipped with parabolic reflector antenna with a diameter of about 2 meters. So it is used for basically for the detection purposes, and this antenna can be movable in 360 degree and can detect this antenna is fixed, but it can move its beam 360 degree all around to track the or scan the nearby areas. Okay, so it was first installed in Italy, and then later on in the last half of 1940s, this particular year, the last half of 1940s, is basically devoted for the development which are initiated in the World War II in the radar technology. Okay, so here these some of these radar, this MTI radar is in your course. You will be going to learn how it works, what is the working principle of MTI radar. So these two radars were developed in this last half of 1940s. This is a mono pulse tracking radar and moving target indication, that is MTI radars. Okay. Then after that, there are many more years are required for the radar development to make this particular technology into full use, or to explore more application related to these technologies. Basically, in 1950s, I can see from 1950 to 1960, continuously theoretical papers were published by the scientists and researchers on the principles, theories, and what all algorithms can be used in radars. And after that, the 1960 is the practical implementation of those theory which are evolved in 1950 to 1960. The next, during 1960s to 1990s, there is a boom in the radar technology, and a lot of applications were explored apart from uh, airborne MTI radar and airborne early warning aircraft, which were developed for the US Navy in 1960s. And some of them were also designed for detecting ballistic missiles and satellites. And some new form of the radar applications were also developed, which are in 1990s, like some of the applications I have given here. uh, uh, Increase information, and we will get increased information about the nature of the target and the environment which to be obtained from the radar echoes. So both the nature of the target and the nature of the environment we are able to obtain from the radar echoes. And these are some of the radars examples I have given here, like Doppler weather radar. This Doppler weather radar, the example I have also given next rad. The Doppler weather radar measures the radial component of wind speed as well as the rate of penetration. Okay, so the wind speed and rate of penetration can provide certain new hazardous weather warnings. Okay, so these weather warnings are very useful for weather forecasting and for the aircrafts also. Like if those aircrafts are going in that area, so in airports, these warnings are being used, and such type of radars can be employed over there, and for saving the life of people also. If there is certain dangerous levels of winds which are coming that are very harmful for the human lives or any kind of human property, or for the uh, other flora or fauna, so they can be saved by the time. And terminal Doppler weather radar TDWR. These are basically installed at or near major airports to warn of dangerous wear shear during takeoff and landing. Okay, so they are being basically used for air traffic control. Air traffic control means in air, the traffic is basically of aeroplanes and aircrafts only. So in like we have the traffic control for land, so we have a traffic control for air, and the traffic control for air is carried out by radars. Okay, so like which aircraft is to land and which aircraft should take off. So these all decisions are being taken by studying these data coming from these terminal Doppler weather radar. If the weather is not suitable for takeoff or landing, so such type of signals to be provided to the pilot of the pilots, so that they can be informed about the um, uh, prior inform before the landing and takeoff decisions. Okay, then this is HF over the horizon radar system. This HF over the horizon radar system basically uh, primarily used for the detection of aircraft at very long ranges, up to 3,700 kilometers. So you can basically de detect the aircraft by using this particular radars to a very long range. Okay. Then next is the space-based radars. A space-based radar continued to gather information about the Earth, land, and sea surfaces on a global basis. So this is all about we get information about the Earth and sea surfaces, and improved imaging radar system. These are carried out by space probes to obtain higher resolution three-dimensional images of surfaces of Venus, Mars, and other planets, penetrating for the first time its ever-present opaque cloud. Okay, so this is all about the development which was taking place in 1990s in the radar technology, because these radars is now used for the other applications also apart from wars and apart from defense. Uh, Here I have mentioned certain radars which were developed in 1980s. In 1980s, basically the radars which are developed are able to distinguish one type of target from another. Basically, sometimes there are multiple targets which are present in the target area, and a single radar will get confused about the actual range and distance of a target, of single target. Because if all the targets are moving and the target area is scanned by the radar, so the radar is confused that which echo signal is coming from which target. So such for solving such type of problems, phase array radars were used. They can detect the phase, and there is an array of radar, so they can detect the change in the signals and continuous change in the signals which is coming. So the Patriot Aegis systems is an example of such radars. Airborne bomber radar B-1B, aircraft and ballistic missile detection POWs are the examples of such radars. In 1970s, basically the modernization of the radar technology has taken place, where the digital data acquisition and computing by using computer is included into the radar, and this technology is able to reduce the error and increase the accuracy of the radar data. Okay, so the examples I have given, this is Air Force Airborne Warning and Control System radar and military airborne intercept radar depend on the pulse Doppler principle. Now, radars for defense during 1990s. So during 1990s, I have already told you that the radar technology has taken a new turn by exploring the application of the radar to imaging, to remote sensing, weather forecasting, and air traffic control, because this is certain civilian applications, and before it only the military applications of the radars were realized. And in 1990s, there is a war which is called a Persian Gulf War taking place, and after that the use of the radar has come into existence, or you can say that again it was used for the defense purposes, and this is the gift of the anti-ballistic missile treaty which was taking place between Russia and Soviet Union. um, and in the Persian Gulf War, there is a lot of use of tactical ballistic missiles. So the only choice is to use the radar for the defense purposes also. So again, such in 1990s, radars have again used for the defense. And this anti-ballistic missile treaty is like when you use radar against the ballistic missile. So uh, it, so it is legalized at that time. So in 1990s, a lot of changes, global changes taking place, because initially there is US which is there to develop the radar technology for the war purposes, and now after that the Russia come into existence in around 1990s, and it has enhanced its powerful radar-based air defense system to engage tactical ballistic missiles. So to handle such kind of missile, it has uh, it has strengthened its air-based, basically radar-based air defense system. So in a radar-based air defense system, India is also having a radar-based air defense system. So in the aircrafts were there which are equipped with the radars, and they are able to detect and destroy the missiles. And this is called a anti-ballistic missile means is system. Okay, and then the second country, which is Israel, it deployed aero-phased array radar as a part of anti-ballistic missile system to defend their homeland. Okay, so anti-ballistic missile system, to incorporate anti-ballistic missile system, you should also have radar technology with you. Then only you can implement it. Otherwise, you cannot destroy the missiles which is coming from the enemy. You are not able to detect from where they are coming, and definitely they are going to produce a lot of property and you can human damage. You can see. Okay. So here the in 1990s, one thing is there. United States developed mobile active aperture phase array called theater active altitude area defense ground based radar. Okay, for use in theater wide anti-ballistic missile system. So this whole development taking place in 1990s, means in 1990s the radars were utilized. The application of the radar has been extended in the defense area. Yes, introduction of radar in India. See, you have already know that India got its independence from the British rule after 1947. So, after 1947, the condition of the country is very poor. So, actually, to build and develop its radar, the country should have a good scientist and financial support, and it should have an stabilized research backbone for that. But unfortunately, the work has started so late, and it is started for the armed forces, which is begun in 1967 to 1968 period. And the first, you can see the first laboratory where such researches has begun is at Bangalore, and uh, it is electronic based radar and development establishment called LDRE. It is a premier institute of DRDO, Defense Research. DRDO, not DRSO. I had written wrong here. It is DRDO, Defense Research and Development Organization. Okay, initially they form short range 2D system, but currently they are manufacturing high power advanced 3D systems, fire control radar as well as airborne surveillance radars. So airborne surveillance means they will scan the area over the space, and they will able to know about any enemy spacecraft over there or not. Hmm. Recently, this LDRE, okay, is developing radar equipment for better ship survivability due to improved performance. So these are developing radar for ship survivability, and some of the radars which are developed by LDRE are Indra, Rajendra, Central Acquisition Radar, Swati, Weapon Locating Radar, WLR जिसे कहते हैं, अश्विनी radar, Arudra radar, battlefield surveillance radar. These radars help in countering terrorism and infiltration, especially in line of control and other borders. Further, it helps in locating the Pakistani artillery position with capacity of tracking 7 targets at the same time. So you can understand the strength of any nation depends on its defense capability. So without radars, no nation in this world is able to strengthen its defense. So radars are a very important and crucial part of the defense forces of any country. And this technology is very important to develop, retain, and retain by any nation. And the nation which is very backward in radar technology is not considered as a powerful nation in the present era. So now let's come out from the evolution of the radar to some X-band applications. Okay, so I have already told you the X-band. Okay, this band is below S-band, and this band is having the frequency from 8 gigahertz to 12 gigahertz, and most of the radar applications uses X-band frequency. Okay, so I had given here certain examples of radar application. This is a continuous wave pulse, single polarization, dual polarization, synthetic aperture radar, and phase array radar. So these all are radar. Continuous wave is the means analog form signals were there, and they are being continuously transmitted from the radar antenna. Pulse means intermittent signals. Pulses are being transmitted from the radar antenna at a certain intervals of time, and rest of the radars I will discuss afterwards. Then X-band radar frequencies has been divided into two bands. First is the sub-band, and other is the shorter wavelength or higher band. In the sub-bands, frequencies means it is the lower frequencies. This lower frequency of the S band is being utilized for civil, military, government institution for weather monitoring, air traffic control, maritime vessel traffic control, see air traffic control and maritime. This maritime is related to the ships. Like in the water also there is a lot of ship, and if one ship collide with another ship, then definitely there is an accident there also. So sometime due to fog, due to rain, the ships are not visual to each other. They are not अचानक से ऐसे सामने आ जाती हैं दो शिप और टकरा जाती हैं, तो accidents, in that case accidents can happen. In air traffic control also, if one plane come in the line of the another plane, so there is a lot of chances of accidents and collision, and there is a lot of life can be lost in such negligence. So for that, see in roads we can able to see who all are coming, कौन हमारी साइड से आ रहा है, सामने से आ रहा है. So there is no use of radar in such cases. But in case of uh, ships, and in case of aircrafts which are in the air, so there is nobody to tell you कि आप इधर साइड हो या उधर साइड हो, तो वहां पे तो हमें only we can trust only radar technology. And weather monitoring, I had already told you if there is any change in the weather. Now defense tracking, I had already told you what is defense tracking. And vehicle speed detection for law enforcement, sometimes for the cities which are having which are not having a high population. So for such cities it can be incorporated. Then X-band is often used in modern radar. The shorter wavelength, higher frequency of the X-band allow for higher resolution imagery, for high resolution imaging radar for target identification and discrimination. Imagery applications like imaging radars are used for that. I had already told you, like for study of any object which is very far apart from each other. So like study of the soil of any kind of planet like Moon, Venus, Mars, or study of stars, as and any kind of study, you have to use certain radars. Okay, so Overview of radar types and its applications. Oh, so here there are two types of radars basically, a primary and secondary. So we will focus more on primary radars. Primary radars are of two types, continuous wave and pulse. Continuous wave is divided into two types, modulated, unmodulated, and pulse radar is MTI and Doppler. MTI radar is moving target indication radar, and Doppler radar is based on the shift in the Doppler frequency. So these are all the aims. What are the aims of radar? Basically, it is used for detection, tracking. The uh, detection means to know about the presence of a certain target, and tracking means to continuously know where the target is going, whether it is coming towards you or away from you, or what is the location of the target. Okay, and this is tracking is much more advanced as compared to detection. Classification and identification of objects. Classification, which type of object it is, whether it is meant for us or not, whether it is our target or not. Identification, how big it is, what is the size, shape, color. And surveillance means to continuously monitor certain thing. So to if there is a certain radars which are for missile surveillance, so they continuously detect in the environment, or aircraft surveillance, airborne surveillance were there. Okay, so depending upon the application, surveillance radars were there. Then imaging and guidance. Oh yes, the radars are used to guide the missiles also. Means if you are having a missile and you want to send it to the enemy area, so where it should go. So radars continuously provide signal to the missile so that the missile can go to dedicated direction in a guided way. Similarly, if any kind of missile which is coming toward your area, so the radar is able to detect it. Okay. So applications broadly classified into two types: civilian application and military application. I have already told you. So these are the types of the types of the radars. Waveform which are transmitted by the radars is continuous wave and pulse radar. Okay, installation of the radar can be done in four types. Either it only land-based, seaborne radar, which are installed in the ship, airborne, which are present in the aircraft, and spaceborne. Okay, so these are the four types of installation of the radar. Okay. You can see here air traffic control application of radar. I had depicted it with a example of with a pictorial example. So this is your aircraft, and this is air traffic control which is installed at the airport, near the airport. So there are a lot of antennas and air traffic control centers which are installed, and these are for detecting various aircrafts which are come in its line, and to provide them the necessary signal if required. Okay, next slide. So these are the day-to-day application, lifesaver applications and road maintenance applications. Here you can see that this is a person, he is having certain rod in it, which is providing him radar signals, and he can search and take out the trapped people. Okay, and this how the the radars can be used if certain terrorist attack came into existence. So this how these terrorist attacks can damage the buildings, and you can see in the This in America, one terrorist attack takes place around that is called 9/11, and the World Trade Center building was devastated in minutes, and in that building, a lot of peoples were there to detect where the people is actually lying. Radars help it for those also. Then here, the road in road maintenance, which part of the road actually needs maintenance? So you don't know, because the road is made up of various layers. So to see the hidden layers, radars is being employed. And certain applications are also there: tunnel wall inspection, okay, mine inspection, whether the mine is in which condition it is. Then locating underground pipes. With this, how you can locate where the pipes is there. So if any pipe is needing any kind of repair, or where you have to dug and where you have to go, you will get all these data. Then this is locating the grave. So this is how you can locate. You're just showing a cutaway view of GPR data detecting grave sites. So this how day-to-day applications also radar is very important. Is holding a very um, important part. Basic radar application. So what we have learned from this slide is basically there are military applications, security applications, surveillance applications, and weather observation, air traffic control, collision avoidance, inspection of construction work, road maintenance. Okay, and in military applications itself is a very vast topic. So how what are the military applications? See, radars are very important part of the air defense systems. Okay, operation of offensive missiles and other weapons. The radar is very important to guide the weapons also. Otherwise, the automatic weapons will not work. Target detection, target tracking, weapon control. Then track the target, direct the weapon to an intercept, assess the effectiveness of engagement, also used in area, ground and air surveillance. See, in news, recently a news has come. Today is 30th, Thursday, and yesterday only I am listening the news that new Rafale fighter jets are currently being incorporated in the Indian Air Force. So they are definitely increase the capability of Indian Air Force because of their advanced weaponaries. So this system, this Rafale, one of its So this Rafale radar capability includes MICA air-to-air beyond visual range interception, combat and self-defense missile, and in their IR and active radar homing. This active radar homing is very uh, crucial feature of this Rafale. Okay, so I'm highlighting this. We will means see in detail related to active radar homing. So MICA is a missile which is beyond visual range missile. Okay, so it is operated by these RAFALE by both IR and active radar homing. Okay, so beyond visual and visual range both are covered in MICA. It is also equipped with Meteor, very long range at-will air missile, very long range rocket, and ramjet power at-will EM missiles. Okay, so you can see in news it is giving that now our air force can challenge Chinese because now we are having Rafale. So Rafael is having the advanced radar capabilities. That's why that plane is very strong and very capable of dealing with any kind of enemy and to detect any kind of enemy aircraft and to destroy it. At the same time, it is not easily identified by the other enemy planes. Okay, it is also equipped with hammer. It is a highly agile and maneuverable munition, extended range, modular rocket booster, air to ground precision guided weapon series. So air to air, air to ground, both types of missiles are being equipped with RAFALE. Okay, so these are all the guidance systems which all it use. So in this particular slide, I will tell you about how Rafael is able to do active radar homing. Actually, in any kind of missile guidance system, a radar is an integral part. Missile cannot be guided towards the enemy aircraft until and unless it was guided with a radar system. So this whole system is called the missile guidance system, and guided missile hardware is equipped with a radar, or it works with radar. Okay, so our Rafale is a basically it is a aircraft which also act as a launch aircraft. Launch aircraft is always equipped with fire control radar. Fire control radar all guides your missile where to go by sharing the information of location and direction and track information of the target aircraft with the missiles. So, whenever any target aircraft or the enemy aircraft comes near your area, your launch aircraft scan it, able to detect it. How it is able to detect it? The launch aircraft is having fire control radar, and that fire control radar transmits the electromagnetic energy towards the target aircraft and illuminating that target aircraft. And after eliminating the target aircraft, the fire control radar is having a small area or a small radar transmitter which generate a very narrow beam of electromagnetic energy, which is particularly selective towards the target only. And this will able to track the target. Okay, so this how the fire control radar is able to get track information, and this track information is being shared with the missile onboard receiver. The missile onboard receiver is actually getting what? The reflected energy. This is the reflected energy which is coming from the target aircraft, and this signal is now also contain the track information, and this being received by the onboard receiver which is present in the missile. Okay, so this missile will able to follow this target aircraft, and also this launch aircraft will not be in will eliminate target aircraft and also get the, and a narrow beam is again transmitted toward it, and the missile will get the tracking information. So this is how the missile is guided towards the aircraft. This was a semi-active radar homing where the radiation is being transmitted both by the launch aircraft and the missile. Missile receive it. In the active radar homing, actually this is very dangerous, because it also eliminates your launch aircraft towards the target aircraft, because there is an exchange of information between both. But if you don't want your launch aircraft to come into scene, and if you want to hide your aircraft, you use active radar homing. In active radar homing, actually the launch aircraft will not in the scene. There is the missile itself is equipped with the transmitter as well as the receiver, to that. This is called the onboard transceiver. Onboard transceiver the missile is having, so it can transmit the signal towards the target aircraft, and it can eliminate the target aircraft. Okay, and at the same time, it will also get the tracking information from the target aircraft by the echo signal, and it can follow the target aircraft, and the launch aircraft will can go away, and can also do another piece of work by the time this missile track this aircraft and destroy it. So the missile has the required electronic hardware and software. This missile is having all hardware and software to find and track the target anonymously, and does not depend on the services of the external launch aircraft or any kind of earth station or external radar transmitter, as it does with in case of semi-active radar homing. So this how you can see that active radar guidance is commonly used for terminal homing in anti-ship, surface to air, and air to air missiles. So both active and semi-active missile guided system have its associated advantages as well as disadvantages. On one side, the active radar systems are having complexity and cost. The semi-active radars have the advantage of being low cost and less complex. But active radar systems are more secure as compared to their semi-active counterparts, because active radar systems uh, uh, the launch aircraft will not into existence after the missile is launched, and the missile itself is equipped with onboard tracking systems to track the aircraft, to track the enemy aircraft or the target aircraft to destroy it. Whereas in the semi-active radar guided weapons, the aircraft or the launch aircraft is always vulnerable to the counter attack from the uh, enemy side, and because the radar itself acts as a beacon for counter attacking the missile, because the radar also is connected to the missile, and the missile is also getting the echo signal from the target aircraft, so both are vulnerable to attack. Whereas on the active radars, they are more secure, and but they are having the disadvantages of size restriction, because the transceiver is located on the onboard transceiver is located on the missile itself, as well as it is having a very complex circuitry. So you cannot increase the size, as well as it cannot provide the guidance alone to a long range missile. So these are the disadvantage of active missile guided system. Um, so far we have learned about the radar advantages, disadvantages, and we are able to know what actually the radar did or does. Basically, radar is being used to find the velocity, range, position of the target object, and they are able to have superior penetration capability, and they are used for radio remote sensing, as well as for weather monitoring to find the type of weather condition. Also the hidden objects underneath the earth, and for the defense and air defense system, land as well as the maritime defense services, or civilian or any kind of military applications. The lidar is one of the advanced type of radar that uses visible light from laser to do the same operations as radars. Radar part constitute of unit number 5 of your syllabus, and your book which you according to your syllabus which you refer is M Kulkarni, Microwave and Radar Engineering, third edition, Umesh publication. I had already written it in the first priority. Rest two book are also shared in this slide. Sconlic and other one is this Engineer's Garage types of radar. So thank you all for being with me in this lecture, and I'm hoping you that now you are able to understand the basics of microwave and radar engineering. And from the next lecture, we will be covering our unit 1 and some part of unit number 5, both simultaneously. Uh, uh, Talking about the DHA part, I will be uploading the DHAs. So we have covered all the introduction related to microwave and radar engineering, and two DHAs multiple choice type will be uploaded on Moodle CMS. So all those who are not having the login and password of Moodle CMS, please create and please attempt the DHAs from there, and each DHA will be of I think 5 marks and 10 questions. So please attempt it from there. Thank you all of you. Have a nice day, and I will be coming in the next lecture soon. Thank you.